Okay, so first thing we're going to do is identify everything that was given to us. So me personally, I like to draw a picture. Okay, so you have a river here. So you know you're not going to need any fencing material there. Okay, so you have this, we'll call that X. You have the two sides, which is Y. And we know the area inside of here is 180,000. Okay, so it's given that X times Y is equal to 180,000. Yep. Let's say area equals X times Y. So X times Y equals 180,000. Well, I guess technically this should be a straight line since we know the area. There we go. Okay, so our primary equation for our second step we need to know how much fencing material we'll need. So we'll let S represent the length of fencing material. Okay, so that means S would equal X plus Y plus Y. So X plus 2Y, since we don't need any along the river. Okay. So we couldn't necessarily use the perimeter that we used before because we are missing a side.
Could you solve this problem by doing 2x plus 2y again and then subtracting x from the end? Or would that mess up the numbers?
It could work. I'd have to actually work it out to see if it would work. All right, so third step, you want to have just one independent variable. Okay, so we know if X times Y is equal to 180,000, you're going to make Y equal 180,000 divided by X. Okay, so that means that your S that equals X plus 2Y now becomes S that equals X plus 2 times 180,000 over X. So S equals X plus 360,000 over X. Okay, so now for our fifth step, we look for our, well in this case, minimized fencing length. Nope, forgot our domain. And again, for your domain, it's really easy if you don't have to use it, because in this case, X and Y just has to be positive, so it's not really one of those extremely necessary steps. Just good to know stuff. Okay, so now for your fifth step, determine the, in this case, minimized value. Okay, so we need to know that the first derivative of S with respect to X is equal to, that derivative of X is just 1, plus, And we'll go ahead and find the derivative of 360 360,000 times 1 over x, which is just x to the negative 1. Okay, that's equal 360,000. If we bring down our negative 1 and subtract 1, x to the negative 2. So it ends up being 360,000, well, negative 360,000 over x squared.
I think you missed the 0 on the 360,000.
Oh, you are right. Thank you. All right, so we have minus 360,000 over x squared. Okay. Just like before, we have to find out where that first derivative is equal to 0. Equals 0 just means that 1 minus 360,000 over x squared equals 0. So just like before, if we add 360,000 over x squared to both sides, you have 1 equals 360,000 over x squared. Multiply x squared to both sides. Square root both sides, we get x equals 600. Okay, so we have our length of fence here. Now we need our sides, but just handy enough that we have our y right up there. Bring that up just a hair. Okay, so we know that y equals 180,000 over x, which is 180,000 over 600. So it means that y is equal to 300. Might as well put the meters there. Okay, so if you make x equals 600 and y equals 300, that would be the minimum length of fence that you would need. So basically 900, 2 times y, I forgot about that. So that would be 600, 1,200. And I can probably squeeze that right here in the bottom. Most of them will just ask for your x and y values, but this is kind of a quick overview of the entire thing. So s equals x plus 2y, and 600 plus 2 times 300. So 1,200 meters of fencing. Where I start up here and it looks like I have all the space in the world and I still end up squeezing it right in the corner. All right. Any questions on this one? All right, leave that up for a few seconds.
So this one,
Mm-hmm.
if the river wasn't there, we would end up with another square, wouldn't we?
Probably so. No, hold on.
We got 1/2 of y.
No, because 100 is, you can make that a perfect square because it's 100 for the entire one. So with this one,
Well, you have 3.
probably not, because x and y are different values.
I thought, but it's actually 1/2 of that though, right?
Yep, so if you have, for this one, actually I'm going to have to figure that one out because that's a good question.
Sure, it would be.
I'd have to see. It's possible.
I think
It's a good question. I have to figure that out if I'm bored. All right, go ahead and start on the next one. Good. Okay, so what if we have a car rental company? Charges its customers P dollars. We don't know how many. We just call that unknown number P per day to rent a car. But we do know that it's somewhere between $45 and $200 a day. Okay. Now the number of cars that they rent per day actually does have a linear model. So the number of cars rented per day can be modeled using the linear function and of P equals 800 minus 4P. Okay. So they want to know exactly how many cars how much should they charge to rent a car if they want to maximize their revenue. Because you charge too much, not enough people will rent it. You charge too little, you don't make enough money. So they want to know that perfect balance. Okay, so how much should the company charge each customer per day to maximize revenue? Okay, so we start with our first step, what's given to us. Okay, so we know the number of cars rented, they gave us that formula. So NFP equals 800 minus 4P. So number of cars rented per day. Okay. And they gave us that, but that kind of falls under our domain, so you can put it up here if you want to. But I'll just save it to the fourth step, just to stay on track. Okay. So now for our second step, we need our primary equation. Okay. So we know since we want to maximize revenue, we have to find the equation for revenue. So revenue is equal to the number of cars rented times the price you charge. Okay, so we can make our revenue equals N times P. Okay, so our third step is we want to get that equation, that primary equation, to make it have one independent variable. Okay, so we know that R equals N times P, but we also know that, don't want to think that's multiplication there. Since we know that N is equal to 800 minus 4P, we can actually make that R equals N, not N, 800 minus 4P times P. Or if we want to simplify it by just distributing that P, our primary equation could be R equals, I'll say negative 4P squared plus 800P. Just flip them around. Okay, so this is our primary equation. Oops, there we go. Okay, and the fourth step. Your domain. In this case, it actually is one of those things that's necessary. Before, it didn't really make a whole lot of sense because you kind of knew that the length of a fence side couldn't be negative or something like that. But for this one, it's necessary. And they gave that to you up here, that the price has to be between $45 and $200. So 45 is less than equal to P, less than equal to 200. Okay. So now we just have to find our fifth step, which is finding our, well, in this case, maximized value. Okay, which means we have to find the first derivative of our revenue. So the first derivative with respect to P is equal to, bring down our 2, we have negative 8P. Forgot a 0 there. So that should be 800. Plus 800. Plus 800. Okay. Now to find our maximum point, we have to make our first derivative equal 0. Or our critical point, rather. Okay. Which means that negative 8P plus 800 has to equal 0. Okay. So if we add P to both, add 8P to both sides and divide by 8, we end up with P equals 100 as our critical point. Okay. So now we know we can't use the second derivative test or anything like that because they already told us that it's a linear function. So the second derivative test is going to be 0, so it will be inconclusive and we'd have to use first derivative test or anything like that. But you really don't have to because you have our critical point. You want to find out, okay, if at 100 is that we get our maximum profits or maximum revenue, or do we even go to our endpoints and maybe those would give us our maximum revenue? So we actually test all three and see which one gives us the most profit. The most revenue. Okay, so test R of 100. R of 45. And R of 200.